So hello, I'm Matěj. Thanks for coming. And I would like to start. If you can raise your hand, who was on meetup by Uplifting? It was like 2 weeks ago about modern architectures. Were there anybody of you? Only a few of you, but it's great because this is kind of follow-up on that one. Uplifting, it was more in theory. Today it will be more practical and about our experiences because Standa Gurník from Rovy spoke about actually Monolith architecture, and also the first presentation about Kafka messaging is quite related to architecture here in Productboard. So, a little bit historical context. As probably every startup, also Productboard started as a monolith application. At the time, it was Ruby on Rails application, and then started a big growth. And it was before COVID, and we thought that this growth will continue. And microservices was all around, so we thought that we all also need microservices and started building a microservices architecture using Kafka as a protocol to communicate between them. But we found issues with such approach. One of them is that when you are sending events and you need to reply to synchronous communication, like HTTP communication, it's problematic because you don't have a response. You need to propagate somehow the response to that synchronous request. And also it after COVID, we need to accelerate the development, and it didn't scale very well. So we needed better productivity and somehow also quickly propagate changes in our source codes. So when you are building microservices and different repositories, so propagation of the change can be problematic. You need to be backward compatible. You need to document your APIs and so. We wanted some easier way how to modify the code owned by other teams, and we still wanted somehow separate the responsibility of different teams. So we came up with the new architecture, which is Modulith. And Modulith, I asked ChatGPT what it is. It's a modular monolith, meaning a system structured into well-defined modules, but still deployed as a single unit. And it balances the modularity and maintainability without the complexity of microservices. And here is the picture how it can look like. So you have one single unit with different modules which can communicate between each other. They can communicate outside, and they can even share database. I will get to that later, or they can have their own database. We knew that bringing a new architecture can bring some risk, and we should tackle them. So we should be aware that we should not access internals of other modules. We should, because when you have one code base, there is risk that there will be higher coupling. When you have a huge code base and a lot of modules, you can have slow CI pipelines, different modules can have flaky tests, so there can be pipeline instability, and also there is a problem of ownership of different modules. We will hold on calls for that, and you need also somehow coordinate delivery of different features between teams, because maybe it's beneficial when one team will deliver the part of the feature in their code base, and the rest, for example, will be delivered by other team. Here are some requirements we had for the Modulith implementation. So we wanted to have enforced contract during the build time. Of course, like we didn't want to have or integrate the Moduliths through the database. We also thought about possibility to extract the module as standalone service, because maybe how the deployment evolves, the application evolves, you need extract actually the module into standalone service. But for now, we wanted to deploy everything as a single application. Then for testing, we needed or we wanted that to test each module separately, and then somehow test everything together. Of course, like end-to-end tests, kind of. And for the observability, you need to have metrics separated by tags. So you know that this metric is connected to this module or that module, and also this separation is needed for logs. Because from the point of deployment, it's still single unit, right? We looked at the Spring Modulith and Gradle modules more closely, but at the time when we looked at the first at Spring Modulith, it was not major enough for us. Although we know that it was originally like different library, and then it was kind of taken under Spring. But when we looked at it, the version was 0.2, so for us it wasn't major enough. Also, it has it had or still has more disadvantages than Gradle modules, especially because in Spring Modulith the inter-modules communication is based on events, and we wanted to have possibility to call API calls directly. Yeah, and so then we checked if we are able to use single Spring context, or we can use or we wanted to use Spring context per module. It turned out that we want to use Spring context per module, and mainly because of module separation, it allows you to have module-specific configuration, ability to run on this single module, and also observability. That single Spring context is also one of the disadvantages of Spring Modulith project from my perspective. So the solution we came up with is Gradle submodules separated into different Spring contexts, and to have like strict separation between modules. Each application module will have at least two modules, one API module and one implementation module, and the intercommunication between these modules will be only through that API module. How it will work, how it works, I'll get to it later on image and maybe in demo. Yeah, and that's mentioned here. And on that image with database, it looked like weird that we are integrating services through one database, but we use only one database because of pricing. We use one RDS, but each module has a different schema and like separated users, so they can't communicate together through database. And it also simplifies potential extraction of such module, because like they actually have their own database, but it's schema as a like in the implementation, and that separation by API modules is achieved by Gradle task. So we have a Gradle task which checks that one module doesn't depend on other module by anything else than its API module or submodule. So what is Spring Application Context? Because maybe it's not clear for or not known to everybody. So Spring Application Context is central interface to provide configuration of the application. And usually when you are working with Spring and Spring Boot, you are working only with single application context. And this application context contains beans. It handles also internal Spring eventing. It handles resources, so like configuration when you load resources for configuration, and for example, internationalization. And what is possible, and that's what is kind of unique, and not many, I don't think that many companies are using, is this context hierarchy. So here is an example how you can configure your Spring application with context hierarchy. You can have one parent, multiple childs, and you can build a tree of different contexts. And what is interesting is how beans and events are propagated through these contexts. When you send event from your submodule or from your chart context, it's propagated to your parent. And child context sees beans from the parent. So maybe now you can imagine what we used for implementation. Like we use this fact for implementation of Modulith in Spring. It's based on blog article which was suggested here from Lukáš Křečan. It's written from his by his friend Novoj, who is, by the way, I think still he's organizing JOpenSpace. Yeah, still. Yeah, so the solution is that we want to register some beans in the parent context, and we want to propagate some events to child context. And how it's done is that when we have a child context and we create some instances of the specific implementation, this Modulith event, we resend them because each event actually from a child context is propagated to the parent context, but only events of this implementation are propagated to child context. This is our implementation, like which is handled in the parent context, and similar in beans. So when we initialize beans and when there are instances of public module interface, then we register them also in the parent context, and so they are visible also in other child contexts. So that means that then, that's what I actually said, that child context, because they have access to beans in the parent context, we can access them and we can normally auto-wire them as you would instantiate them in your normal context. time do we have? Okay, so we have even time for showcase. I pushed the example code also to our GitHub, so later you can check it. There's also a QR code with link to the repository, and I prepared simple application where we have like 3 different modules. One is REST API, then we have module for entities, and other module with for audit log. That REST API combines calls from entities and also audit log, and then we send events from entities module to other module. In this case, it's consumed in audit log. Yeah, so that you can imagine that. Like how it would work in the real world. So I'll try to switch to that code, and so basically you will see that for the main flow we are using method calls, and that word beans from other contexts, and for side effects, because audit log can be considered as a side effect. We are using that even thing, and yeah, that's probably what I wanted to say. So let's see. Yeah, let's see if I can switch, and I'll try to. Maybe I can still speak here to this microphone. Okay, so yeah, and I'll make it a little bit smaller. Good. So this is that test project which I, sorry, bigger. Okay.
Maybe a lot of like sleeping idea.
I'll try. Yeah. Okay. Like for the so the first thing I mentioned is that we want to check that we don't rely on any other project than API project, so that's done with this check project dependencies in the Gradle build, which does exactly what I said. It checks that we can depend only on libraries or like project modules which ends with suffix API. Then when I open the main file of the application, it's here. So I have like standard Spring Boot application. There is and I set up the parent context, and then I set up different child context with different application types. That's similar to what you saw on the example in the presentation, and what we do is that each submodule has different name of the Spring config, so we can distinguish which resources file depends to which module, because in the end it's everything on the same class path. I'll get to that later, why it's problematic in some cases. And And about the, I'll start with events propagation. So we have something called forward to children listener. It's and when this event which is consumed by this listener is instance of Modulith event, then it's propagated to child contexts, which are registered in this child context registry. How the bean propagation is done is that we have some application context initializer, which is registered here during the. Sorry, here. Yeah, that's the same. So here, which is registered here, and so during the bean initialization, if bean is instance of public module interface, we register it also to the root context. We have like the link to it to the instance of the root context. Then. When you look on the structure, I have entities API where I have entity service, and this entity service is instance of public module interface, and implementation of this service is in entities module, there is this entity service implementation, and this bean and my other modules can depend only on entities API, because that's given by the rules in Gradle task. But like the bean implementation is like in different module in this entities module, but still it can be propagated to the parent context, and in the parent context it's visible to other submodules. Yeah, and maybe I'll switch back to the presentation. So for us, it's working like quite good. We like it. It really improved our effectivity, the time to deliver features. But there are some issues. One issue is that everything is on the single class path in the end. So, for example, if you that's the problem in Spring Boot. You have these auto configuration which are like configured conditionally on some presence of library or classes on the class path. So when you have everything on the same class path, then in your when you don't exclude this auto configuration, these parts are configured automatically for you, so they can so you can, for example, configure your data sources, although you don't need any of them. For some cases, it's necessary to exclude quite a lot of things when you have a really simple module. Then there is still problem which we weren't able to come up with good solution is like when you test your module, it's still only isolated tests, and these beans which are wired from other submodules are usually mocked beans. So you just mock the behavior, and then we don't have like robust enough tests which would test it like with like real cases. So this like feel of safety that you test everything is only given by the like can be broken by the fact that you just mocked the implementation, and the reality can be different. then this project starts to be quite big. So the duration of the pipeline prolongs quite a lot currently, and we are looking for some improvements, and we are aware of some improvements like better Gradle caching, Gradle Enterprise, or NX, for example, like using different build system. Then we had issue with ownership, because originally when you refactored something and this refactor affected multiple submodules, these submodules were usually owned by different teams, and when you got approvals, and you replied to comments from the code review, you lost all of these approvals. So you need to ask for approvals once more. This is something which we removed, and it highly helped us, because it was like really a headache for bigger refactoring. So now, once it's approved from somebody from a responsible team, you don't lose your approval, although you then, for example, touch the code again. But we have never encountered any issue with with that approach. Then, of course, like this propagation of beans from submodules to root and then back to submodules is not supported by IDE. So then you see it as no implementation of such bean is available, but it's actually is. So you have to live somehow with that, but it's not so big issue. And what is maybe bigger problem is modules dependencies, because one module can depend on other module, and this module can depend on other module, but that module depends on the first module. So you can create circular dependencies. It's kind of forbidden, although also by Gradle, but it's not only it doesn't have to be. It depends on the circumstances. It also depends on the initialization order. So when you encounter that situation, we have a rule that when you have problems with modules, more modules solve that issue. So we just split it into more modules and break this circular dependencies. So that's actually a rule we also learned from Krzysiak. Yeah, and quite surprisingly, we haven't encountered any issues with the smaller bust radius which Modulith deployment give us. So although we have everything in a single application, we for 2 years since we started using it, we haven't encountered the issue that like one submodule would affect badly other modules in the fact that the whole platform wouldn't work. So that's it. I'm exactly on time. That's great. So thank you for your attention. And what are questions? Have you tried gRPC? No, we haven't. We haven't. There is. I don't know how was this meant, but there is probably no difference between gRPC and like REST API calls, right? Or how was it meant? We used Kafka, so all modules like in that original architecture would be standalone as possible. So they would own their own view of our platform. So we used Kafka to synchronize data. And of course, now when we are using Modulith, these API calls, because it's on the language level, it's extremely fast. You can't be faster than when you are in the single JVM. Yeah, did I answer it? Did I answer the question? How many Gradle modules do you have? How large? How many classes? Total build time? Yeah, so when I build it from scratch, including all our tests. It's currently about 5 minutes locally. So it's quite a lot, but I usually work only, like that's the problem when you need to deploy a hotfix. When you are working on your machine, usually you're working only on single module or something. And totally, currently, we can have around, like it depends if you mean like main modules or also submodules in that modules, because that's also possible. But we have around like 8 main submodules of the project. Like so imagine it this project is contained from 8 other projects, and in these we can have like four other modules, for example. So it can be around 30. Yeah, so around 30 submodules. Yeah, so how many classes? I don't know. That I can't answer that question. The main advantages of microservices architecture are scalability and fault isolation. Isn't it lost in modular architecture? Yes, exactly. But that fault isolation in microservices architecture can cascade, of course. So you need to use some resiliency mechanisms and scalability also. But like what? In which scale you would have to be to need like that kind of granularity of scalability. So because you usually need at least 3 pods on Kubernetes, so that's also a problem with the microservices architecture, that it starts to be quite costly or expensive, right? Because when you need for each microservices, now we have we have only like a single deployment. We give it some CPUs and memories and so on, but if we would see problems, because, for example, in our case, we have one application which has totally different JVM parameters than all other applications, we are thinking about moving this module to a single application. We can, yeah.
So how many instances of this Modulith is running in production?
Yeah, I think by default it's basic instances is 6 or 8, and it can be scalable to 24, depending on the scaling of Kubernetes scaler. How many teams and people are working on this code base? It's a good question. Currently, I think it's about 7 teams, and it can be almost 70 people. Have you considered Git submodules to solve the issue of ownership and collaboration? No, we have ownership files, and like I don't know how it would help. Like with submodules, there's if I remember correctly, there are some issues that you need to fetch these changes and so on. Yeah, like currently with Modulith, I don't think, like since we removed that problem with removal of approvals, we don't have issues, I would say. What is the largest organization change along the journey? How do you overcome it? Organization change. Well, I don't think that this needed organizational change. We had organization changes, as you probably know, but it wasn't caused by a switch to this Modulith. Maybe the thing is that because it's so easy to implement some changes, so Other teams can work in your code base, of course, and it's actually beneficial when you don't have time to implement something. So you don't have to be like too much like sensitive about your code, and you need to be like fast on code reviews because you don't want to block other teams. What is the underlying server? How do you handle efficiency of thread usage? Green threads, coroutines, maybe. That's a good question. Underlying server is Tomcat with like, and that's a good question because I'm not totally sure if it's one Tomcat with different dispatcher servlets or it's like multiple Tomcats. I would say it's single. Yeah, I think it's single Tomcat with different dispatchers because each application on the Modulith runs on different port, or it doesn't have to be servlet application, of course. So then each servlet would have its own thread pool, and like usually. You don't have to care about, like, we don't have issues with threading or running out of the threads. And when we need to run something in parallel, we currently use coroutines. Yeah. But it's blocking it's still blocking the main thread of the server. What is the flow for deployment? Can you deploy just single module? No, because it would mean that it wouldn't be, I'll read the question. What is the flow of your deployment? Can you deploy just single submodule? What happens when there is untested submodule, but the other needs to be deployed? This is Modulith, so it's single application. It needs to be deployed completely. It's like not split by any like containers or OSGI or something like that. This is not monorepo, but Modulith, so you can't deploy only on a specific submodule. We are thinking about using monorepo currently, so maybe next time. What would you consider as a turning point for using microservices architecture instead of Modulith? Like we are still kind of using microservices architecture for part of our for part of our platform because we have different parts of the platform. This specific part is Modulith, and probably when, as I mentioned before, when the application or module somehow affects the rest of the Modulith, then it's time to extract it and probably use it as a microservice. So that would be the time, and we are thinking about one of these modules for the extraction because this, like as I mentioned, this module has specific JVM parameters. Can different teams touch other teams' modules, for example, if they need some data or even publish from that module? Yeah, of course, yes, that's clear, and that eventing is actually beneficial because single event can be used on different places. So we have audit log, we have history, so that can be used, or we need to recalculate something, then these events can be reused. And that's one of the biggest benefits, that when you are working on single code base, also other teams can collaborate on that one. Can you name more disadvantages of microservices? Scalability is advantage. Problem with sync calls can be solved with mix of events and REST API communication. Maybe the biggest problem of microservices is that you need to somehow maintain the backward compatibility until you change all your clients. Of course, there is still some latency between for these calls. you get some penalty of that communication. In Modulith, when you need to change something, when you need to evolve fast, maybe because or each time you don't know exactly your architecture, how things will be separated, the boundaries, how objects will look like, because maybe like you will need something else a little bit later. This possibility to change everything and propagate the change from singular factor is probably the biggest advantage of Modulith. And disadvantages of microservices, I mentioned the latency, problem of cascading of the failures, and I think that more of it can be read on the internet. I can't recall now. What about rollbacks? Is it possible, since you would be rollbacking possible unrelated changes from other modules? That's a good question. Ideally, you should find your issue until other deployment happens. If not, then it depends on the context, of course. Yeah, but that's a good point. Yeah, of course, when you don't realize that or in the meantime you get more changes, you probably the only possibility is that the outage will take longer because you need to revert the change in the code and make another deployment. You can't just change the deployment in Kubernetes. How do you, OGI modules. How do you handle Git, multiple teams working on different features? How do you handle breaking changes and their propagation in other modules? You exactly see how breaking change affects other modules, and other teams can directly review the change, because the change is propagated to their module, so they can provide you immediate feedback. That's probably the easiest way. With microservices, that wouldn't be possible, and they would have to check what changed in your API and how it would affect their client and the propagation to their modules. Standard Git flow process. OSGI modules. I think we haven't considered it. We didn't consider it. I know that Křečák at the time mentioned some other project with these containers in Java, but we even didn't look at it. Where are events stored? Kafka notoriously can handle huge pressure. Is there a big downgrade with new? Notoriously can handle huge pressure. Is there a big downgrade with new events? I probably didn't get the question. Like Spring events are synchronous, basically. So if you don't set it differently, so they are processed during the flow of your request. They doesn't have to be stored, and Kafka has its own storage. When there is huge pressure on Kafka, you get bigger lag, and it depends how you configure your partitions. But usually, like you need to be able to handle this big pressure in some reasonable amount of time. What are specs of the single instance of Modulith CPU? I don't remember. I think we use. I can check maybe. No, I can't. I don't have it opened. I don't remember from top of my head. I think we have maybe 2 CPUs, and well, but it's minimum, and we don't use the maximum for Kubernetes, and we have like 6 or 8 gigabytes of like memory for JVM, I think. Load DAO. What is DAO? Yeah, daily of users. That's we don't count it like that, and if it's units of requests per second for each module. Like it's not our maximum of tens requests per second. It's not in hundreds or thousands. The return of enterprise Java bean where all described was solved. Okay. Sorry, I don't understand. Was it from this audience, or do you want to somehow rewrite the question? 1, 2, 3. Oh, I don't understand. So that's true. Sir, and yes, maybe.
Sorry, I maybe misheard your response. How many requests per second these 6 or 8 instances are serving?
To be honest, I don't know, because I'm responsible only for a part. So and I don't think that we have overall overview per all of these. But like what Kai. I think it's in tens of seconds, tens requests per second. Like it's not hundreds or thousands.
Okay.
Yeah. But and usually we scale down, so we have like 6 deployments, and we scale up only when there is like bigger pressure.
Do we have some additional questions from the public, from the audience? All right, if not, thank you so much for your presentation. Thank you so much for all of your questions, and big applause to Matěj.
Thank you.